Human civilization is using more energy every year. Cities are growing. Machines are becoming more powerful. Space travel will require even more. And one day, the energy available on Earth may no longer be enough. We could build more solar farms, more nuclear reactors, more power stations. But all of them would still depend on the resources of a single planet. So if humanity spreads across the solar system, where would enough energy come from? The answer may already be shining above us. The sun releases an almost unimaginable amount of power every second. Earth receives only a tiny fraction of it. Most of that energy passes through the solar system and disappears into deep space. A future civilization might try to capture much more, not by covering the sun with one solid shell, but by surrounding it with millions of independent satellites. Each satellite would collect sunlight. Each would convert it into usable energy, and together they would form a vast structure known as a Dyson swarm. At first, the swarm might contain only a few collectors, then thousands, then millions. It could grow slowly over centuries. One machine at a time. This would be far more realistic than building a solid sphere. A solid shell would require an impossible amount of material. It would face extreme heat. And keeping it stable around the sun would be incredibly difficult. A swarm would be different. Every satellite could follow its own orbit. Broken units could be replaced. New ones could be added whenever more resources became available. But building so many machines would create another problem. Where would the material come from? Launching everything from Earth would be too expensive. A future civilization would probably mine the moon, asteroids, or even Mercury. Metals and minerals could be processed in space. Factories in orbit could build new collectors without sending every part from Earth. Robots would likely perform much of the work. They could mine, transport material, repair damaged machines, and perhaps even build new factories. Over time, space industry could grow almost by itself. The energy collected near the sun would also need to be sent somewhere. Satellites might transmit power using focused microwave or laser beams. That energy could reach space stations, colonies on other planets, industrial sites, or spacecraft traveling through the solar system. A settlement near Mars could receive power from collectors much closer to the sun. Factories in the asteroid belt could operate without carrying enormous amounts of fuel. The solar system could become connected by a giant energy network. But such a network would also be dangerous. A powerful energy beam missing its target could damage satellites or habitats. The system would need extreme precision, constant monitoring, and strong protection against failure or sabotage. A civilization using the power of a star would gain enormous strength, but it would also become dependent on the machines controlling that energy. A Dyson swarm might also change how the sun looks from far away. The collectors would absorb part of its visible light. After that energy was used, much of it would eventually escape again as heat. That heat would appear in infrared light. Because of this, astronomers have suggested that advanced alien civilizations might be discovered through unusual infrared signals around distant stars. A star that appears slightly dimmer than expected, but releases too much heat, could be worth studying. That would not prove aliens exist. Dust and natural processes can create similar signals. But it gives scientists another way to search. Instead of waiting for a message, we could look for the energy footprint of a civilization. Building a Dyson swarm would not only be an engineering challenge, it would also be a challenge of time. The project could take centuries or even thousands of years. The people who begin it might never see it completed. Governments could change, cultures could disappear, entire civilizations could rise and fall. Future generations would inherit machines built by people from a distant past. The hardest part might not be collecting enough metal. It might be keeping society stable long enough to finish the project. There would also be risks for the planets around the Sun. Earth depends on a careful balance of incoming energy. If too many collectors blocked sunlight, the climate could change. The swarm would need to avoid interfering with living worlds. It might be designed around safe orbital paths. Some collectors could redirect energy. Others might even help control planetary climates. But once a civilization begins engineering an entire solar system, every mistake becomes much larger. A failure might not affect one building or one city. It could affect a whole planet. Still, the first steps toward a Dyson swarm might look surprisingly ordinary. They could begin with solar power satellites around Earth, then larger collectors closer to the Sun, asteroid mining, orbital factories, permanent colonies on the Moon and Mars. Each step might appear separate, but over time, they could become parts of one enormous system. The final swarm would probably not look like a perfect ring. It might look chaotic. Millions of satellites, factories, habitats, mining stations, repair drones, and energy relays, all moving in different orbits around the Sun. At the center, the Sun would continue shining as it always has, but humanity would no longer be using only the tiny amount of energy reaching Earth. It would be drawing power directly from the star itself. A Dyson swarm remains only a theoretical idea. We do not have the technology to build one today. We may not have it for centuries. And perhaps future civilizations will discover a better solution. But the idea reveals something important. Humanity may not always be limited to the resources of one planet. If our civilization survives, continues to grow, and learns to build on an enormous scale, the Sun may become more than a light in the sky. It could become the power source of an entire solar system. And perhaps the most fascinating part of this idea is that a Dyson swarm would not only change how humanity uses energy, it would change how we understand civilization itself. For most of history, human beings have lived close to the ground. We built near rivers, we depended on seasons, we measured progress by how much land we could control. But a civilization built around the Sun would think differently. Its cities might float in space, its factories might orbit between planets, its people might be born far from Earth, and spend their entire lives without ever standing on a natural world. To them, the solar system would not be a collection of distant places. It would be one connected home, and the Sun would no longer be only something they watched in the sky. It would become the center of their economy, their technology, and perhaps their entire future.